Hello, this is Ms. DB, and in this video we are going to review how to find the volume of prisms and cylinders. After all the work that you have to do to find surface area and lateral surface area, this should seem a little simpler. We have some formulas at the top. V stands for volume of a three-dimensional figure. Big B stands for area of the base, not one number. It has to be calculated. And h is the height of the prism or cylinder. It's the same thing. It's the height of the three-dimensional figure. So big B again is area. Of the base. Has to be calculated. And h is height of the three-dimensional figure. Let's see, little l is length, little w is width, h is height again. S, if it's a cube, you can call every side S. All of them will be the same. The height will equal the length, will equal the width. You could use any of those letters. And then in a cylinder, the formula is area of the base, or because it's a circle, you could do pi r squared, which is the area of a circle, times the height. It doesn't matter if your cylinder has been knocked sideways, oblique it's called, or the same thing could be true of a prism. It could be drawn obliquely like this. That's because Cavalieri was a mathematician that proved, and a physicist, that proved that the volume will be the same whether or not it has that slant to it, called oblique. It'll have the same volume if it has the same base and height. And then you're going to find the volume of each prism. In number 2, the base is a triangle, so the volume is equal to the area of the base times the height, and the area of the base will be found by going 1/2 base of the triangle with a little b times the height of the triangle, and then times the height of the prism. I'm going to call that h sub p, and this one h sub t. So we would use 1/2. The base of the triangle, little b, is 3. The height of the triangle is 5. Remember that the height of a triangle is always at right angles to its base. And the height of the prism is actually this 8. That's the height of the prism. So I will multiply this is the area of the base, times the height of the prism is 8. If you do that, you should get the right answer. In number 3, the base is a rectangle that is 7 by 2. The height of this prism is 3. So the area of the base would be found by the length times width of this rectangle, which is 7 times 2, and the height of this prism is 3. All right, now when you do the cylinders, you need the radius and the height of the prism. It tells you to give your answer in terms of pi and rounded to the nearest tenth. Let's do number 6. In number 6, we don't know the radius yet. We have to find the radius, which is half of the diameter. So the radius would be 1.5 kilometers. The height is 6. That's what we need, is the perpendicular height from one base to the other. So the volume is found with the area of the base times the height of the cylinder, and the area of the base is pi times the radius squared, and then times the height of the cylinder. So the formula filled in would be pi times 1.5 squared times the height of this is 6. So in terms of pi, you would take 1.5 and square it. So 1.5 squared is 2.25. So this would be 2.25 times 6, and then put the pi after that. We're not going to multiply this by pi if we want to leave it in terms of pi. So I take my 2.25 and multiply it by 6, the height, and that's 13.5. So in terms of pi, the answer would be 13.5 pi. If you're typing, type 13.5 and then write pi. When you write pi, there's no E on that. It's just pi. And then when it says rounded to the nearest tenth, means you take the 13.5 and you multiply by the value of pi. Use the pi button on your calculator. And we see that it's 42.4115. It says rounded to the nearest tenth, so I can just leave it as 42.4 because the number after the 4 is less than 5. So 42.4. Now volume is cubic, so this would be kilometers cubed. Now for number 7, I wrote that this is a bonus, but you should be able to do this. This says find the volume of the regular octagonal prism. We know that volume is area of the base times the height. The height is 15. The area of the base, you have to go back and look up how do you find the area of a regular octagon. In this case, every side of the octagon is 10. So you have one triangle within this octagon. There would be 8 of them. And one of those triangles you can blow up, and then you can use the trigonometry to find the height, the apothem of that triangle, and go back and look at chapter 9 to see how to find the area of this. All right, and then the next part of this is how does the volume change if you change all of the dimensions of a prism or of a cylinder. So for there's 2 examples. There's this example here. The dimensions of the prism are multiplied by 1/3. So they solve the problem as is. This exact problem right there is 216 cubic centimeters. That's the volume. The new volume, when all the dimensions are multiplied by 1/3, or that's the same as divided by 3, would be 8. So the question is, how is the volume changed? And the answer is that it's multiplied by 1/27, which is equal to 1/3 cubed. That's interesting. Remember that the original said that all the dimensions are multiplied by cubed, by 1/3. And now in this example, we have a prism, and all of the dimensions are going to be doubled. So here's the original. Here it is after they were all doubled. The amount that it changes is by 8. 18 times 8 is 144, which is the same as 2 cubed. So again, that's interesting. So for number 8, you're going to say what's interesting about these 2 examples. Then for number 9, it says to multiply all dimensions by 1/2. Remember that in this one, the radius would be 3, not 6. So make sure when you calculate the volume, you're using the correct radius. And then you're going to multiply all of the dimensions by 1/2, or divide by 2, and see what you get for the new volume. And then say, how has the volume been changed from one to the other? The original times what equals the new? Same thing for number 10. And by then, maybe you'll have figured out what the rule is. So if you know what the rule is, you don't have to find the original and the new volume. You can use the rule for number 11 and 12. And in 13, it says to answer what the rule will be. The last part of this, number 14 and 15, you're just going to find the composite volume for 2 problems. In number 14, find the volume of the cylinder. Find the volume of the prism. Add them together, and you'll have your total volume. In 15, find the volume of the first cylinder. Find the volume of the second cylinder. Add them together. You'll have your total volume. There's nothing to subtract from these. There's no hiding parts to worry about. You just find the volume of each part and then add them together to get the composite volume. That's it. If you have any questions, come to my office hours or to the ASC room, or email me for more help or to set up a different time to meet. Thanks very much and have a great day.